Alright, so we're going to find the inverse of this graph. Two different ways, I'll show you both. The first one is to reflect the original over the line y equals x. So if we draw the line y equals x in there, we're basically just going to reflect it across. It's a difficult reflection. It's a little bit harder than flipping it over the x or the y, but basically the points are going to be the same distance on either side. So we're going to go through, and that would be the reflection. The second method, which I usually prefer, to be honest with you, is to take all of the original coordinates and you just flip-flop them. So let me sketch this out real quick. Let's see here, -2, -3, 0, 0. So this was the original, to the best that I could draw quickly. And I've already got the points here. All that you do is you flip the x and y and plot the new points. So if 3, 1 was a point on the original, that means 1, 3 is a point on the inverse. So 1, 3. Let me do this in a different color. If the point 4, 4, I forgot to write this one up here, was a point, this one's not the best example, that means that 4, 4 is also a point on the inverse. We got 0, 0. -2, -3, that means -3, -2 is the point on the inverse. And then you connect them, and that would be your inverse. So either way, you'll get the same result. I think this method sometimes lets you get a little bit more accurate without the grid. This method with a grid typically can get you a little more accurate, but you pick which one you want. You can do both. Like I said, I like the flipping x's and y's.